So in this presentation, we will start by Maglumi system, general overview. Then we will see all the steps that can be done with the analyzer during the routine, the daily routine, including the preparation before starting using the analyzer, the system test, which is a test that we run every day at the beginning of the day before starting running the sample, and then how to run the calibration on using Maglumi reagent and check the results of the calibration, how to run the quality control. Firstly, how to add the quality control, then how to run the quality controls and to check the results. Then we will see how to run the sample tests, including the normal sample test and the emergency sample test, and then the sample test requiring dilution. The last part is the system maintenance for Maglumi systems. So for the analyzer, so this is the overview of the analyzer Maglumi 800. And different analyzers have different number of position of samples, the slot of reagent also, pipetors, and so on. So how the test is done on Maglumi analyzers? Firstly, we distribute the cuvette. The cuvette will be loaded to the pipetting position. In the pipetting position, the pipetter will add sample and reagent to the cuvette. After that, the cuvette will go to the incubator for incubation. After the incubation finish, the cuvette under 37 degrees during a certain time. So the incubation is different between parameters. The cuvette after the incubation will be sent to the washer for 3-cycle wash in the washer. And after the wash finish, the cuvette will be sent to the chamber. Inside the chamber, we add starters, starter 1 and starter 2. The light will be emitted and the PMT will detect this light emitted from the cuvette. And then the cuvette will be discarded into the dustbin, into the cuvette dustbin. This is the one-step assay procedure, one-step assay procedure. One-step assay procedure. Some other parameters using two-step assay procedure, two-step. In case we have two-step assay procedure, the cuvette will not be, after the wash finish, will not be sent to the chamber for measurement. It will be sent back to the pipetting position to add another reagent, a second pipetting. So the cuvette will be sent again to the pipetting position. We will add another reagent. Then the cuvette will be sent again for the calibration, for the incubation, second step incubation, second incubation. After the second incubation finish, the cuvette will be sent again to the washer for second wash, second 3-cycle wash. After that, the cuvette will be sent to the chamber, add starters, make the measurement, and then discard the cuvette. So we have one-step assay and two-step assay. The two-step assay is used for some parameters in order to avoid the hook effect. The hook effect is when there is not a balance between the concentration of the antigen and antibodies in the sample. In this situation, there will be what we call the hook effect, which leads to the false negative results. False negative results. Even the results is positive, we will get the negative results. So in order to avoid this situation, we use the two-step assay for this kind of parameters. This is the reagent kit design used from SNIPE. It is an integral containing 7 vials. So this is the first vial. This is the 7. And in the vials, we have the microbeads in the first vial. The second vial is calibrator low. The third is calibrator high. So the second and the third are used for calibrators. The fourth is the displacing reagent. And the fifth is the FITC, or the buffer. Then the sixth will be the ABI. And the last one will be the seventh will be the diluent. So the microbeads in the first vial. In the second and the third, we have the calibrators. So we have two levels of calibrators in all used by all the Magnumi reagent. We have two calibrators. The third is the displacing reagent. The displacing reagent is used in some parameters when there is some parameters. The molecule or the target material is covered. So normally the microbeads are linked to the bound with the target material, and then from the other side, the target material will link also with the FITC. With the FITC. Sorry, with the ABI. With the ABI. So in some situation, there is some parameters, some molecules have some proteins that cover the molecule. And these proteins will make the magnetic microbeads cannot link with the target material. And also the ABI cannot link to the, cannot link to the target material. So we use this kind of reagent, the displacing reagent, to remove these proteins from the labeling material, remove these proteins and allow the microbeads to link with the target material. So this is why we use this displacing reagent. Same thing for FITC. For FITC, sometimes the material, the size of the material cannot make the link, or with the ABI cannot happen, or with the microbeads cannot happen. So this FITC will be like a bridge. It helps link the microbeads with the target material. So we will have the magnetic microbead and the target material cannot link together. So what happened is that the magnetic microbead will bond with the FITC. Will link with the FITC, and then the FITC will link with the target material. So it is like a bridge to make the magnetic microbead link with the target material. This is the function of the FITC. Then we have the ABI. So you know the function of the ABI. It is the only way to get the light. The ABI is the marker or the label used to release the light signal. So when it reacts with the starter, so normally the ABI is not releasing the light. Only when reacting with the NaOH and the H2O2, it will release the light. And the last one is the diluent. The diluent is used in the high concentration. In the high concentration, when our value, our results is outside the measuring range. So normally, so this is the RLU. This is the concentration. So normally or let's say, so this is our, this is the results, the range of the results. We can define the normal range. This is the normal range. Normal range. The normal range is the value for the normal people, for the healthy people. But we have also the measuring range. This is the measuring range. For example, the normal range is between 20 to 100, for example. And the measuring range is the range that is reportable by the analyzer, that is displayed by the analyzer, that is provided by the analyzer, by the system. It is, for example, from 1 to 1000. That means that outside this interval, this is the measuring range. Outside this interval, the results will not be displayed, will not be recorded and displayed. So in case we have the results higher than the upper band of the measuring range in this side, we need to make the dilution. In case our results is in this side, we need to make dilution. And then the dilution will bring the results to the measuring range, to this range. This is the goal of the dilution. So normally calibrator, magnetic microbead, calibrator low and calibrator high, and the ABI are always available in all reagent kit. But for the displacing reagent, the FITC and the diluent, they are not, it depends on the parameters. So some parameters has 7 components. Some parameter have 6, some parameter have 5, some parameter have 4. So some of them are always present in the reagent kit, and some components are depending on the kits. On the side of the reagent kit, we have a chip to be scanned with the RFID reader and contain all the informations about the reagent, the master curve, the unit, the expiration date, the lot number, and so on. And we can see on the sheet here on the side of the kit some informations. It contains, you can see the name of the parameter, the component inside the reagent kit. For example, this one is the HCG. It contains microbeads, calibrator low, calibrator high, buffer, ABI label, and diluent. It doesn't contain the displacing reagent. We can see the lot number, the serial number, the expiration date. Then in this table, we can summarize all the consumables we have seen in the previous presentation and that are used in our Maglumi analyzers. We said we have the tubing cleaning solution. It is stored in the room temperature, and the shelf life is 1 year. And we said we use it together with a kit, a reagent kit, and we empty kit, and we input 13 milliliter in vial 7, 13 in vial 6, and 13 in vial 5, and load it in the reagent area. And then run the maintenance every month using this tubing cleaning solution. And we have the wash concentrate. The wash concentrate is used to prepare what we call the wash liquid or the system liquid. It is stored in the room temperature. Shelf life is also 1 year. When we prepare it, it is stable 4 weeks on the analyzer. The bottle is containing 714 milliliter. We said we add distilled water until we reach 10 liters wash liquid. Then we have the cuvette. Avoid direct exposure to the sunlight and storage in the area with the humidity. And then the shelf life of the cuvette is 2 years. You can see that even the cuvette are made by some plastic product, but it has shelf life of 2 years. So don't use the cuvette after 2 years, because in some raw material included in the production of the cuvette may affect the results if the cuvette is used after 2 years. Then we have the light check liquid, which is the used to check the performance of the analyzer. and is the only consumables that we store in the refrigerator between 2 and 8. The shelf life before opening, it is 2 years. When we load the life check, you remember a small bottle. We remove the cap, we load it in the sample rack. We need to check whether there is bubbles inside. If there are bubbles inside, we need to remove them before using the bottle of life check. So remove the bubbles using a tip and micro pipette. The last consumable is the starter 1 and starter 2, the substrate. It is also stored in the room temperature. The shelf life before opening, it is 1 year. When we open the cup and load them on the analyzer, it is 4 weeks. It is stable for 4 weeks. So we said for the preparation of the wash liquid, we use the wash concentrate bottle containing 714 microliter. We can pour all the wash liquid, the concentrated wash in the 10-liter tank, and then we add distilled water, purified water or distilled water until we reach 10 liters. Make sure the conductivity is good, is less than 1 microsiemens per centimeter, and then wait and mix, and then wait until there is no bubbles inside. You can increase the wash liquid loaded on the analyzer by connecting another tank of 10 liter. You need just to connect a tubing between them, and then you have 20 liters instead of 10 liter. If the wash liquid is not enough in the analyzer, it will display the alarm. System liquid is almost empty, which means when you get this error message, you need to prepare the wash liquid. So in order to avoid this message, you need to do it in advance. Next is the cuvette. The cuvette is disposable and made by plastic. Make sure that the cuvette is provided by Snipe, so you can check the logo in the middle here. If you find the logo of Snipe in the middle, it is original from Snipe. If there is no logo, that means it is not original cuvette. It's not from Snipe. And when you load the cuvette, you need to load each time on the loading area. You need to load each time at least 5 cuvette. 5 cuvette. So load by 5, at least 5. Why? Because we have an emitter here and a receptor here. So we have the emitter and the receptor. So if the emitter send the signal and the receptor will receive it. If the receptor is receiving the signal emitted from the emitter, that means there is no cuvette. When there is cuvette between the emitter and the receptor, the receptor will not receive the signal from the emitter, which means that there is cuvette between them. There is cuvette loaded. And then the motor will start working, and the belts will move the cuvette from here to the inside of the analyzer in this direction. So when there is no detection of signal by the receptor, the system will understand that there is cuvette loaded and start to load them and move them inside the analyzer. So if you load less than 5, maybe the signal will not be cut here. So the receiver will still receive the signal and the cuvette will not be detected. This is why we suggest to load each time at least 5 cuvette. In case the cuvette are not enough on board the analyzer, you can get the message cuvette is running out soon. So make sure that cuvette is enough when starting test to not get this message. If you get this message, you need to add more cuvette. Next is the starters. So for the starters, we said we have two buttons, starter 1 and starter 2. So you can see they are differentiated by colors and also by caps. So this is in the new design, we have two different caps, two different color of caps, white and for the starter 2 and brown for the starter 1. And in the tubing, you can see the labels also. So avoid swapping the tubings. Avoid swapping the caps, I mean the tubings or the caps, the same thing. And avoid swapping the bottles. Also, in case you change the lot number, so you use a certain lot number, after a certain time, you change the lot number. The previous lot number finished, so you start using new lot number. If you change to a new lot number, you need to recalibrate all the reagent kit you are using. Another situation is if the starter are of the same lot, but the former one had been used for more than 2 weeks. Also in this situation, even if it's the same lot, when you replace with a new starter, you need to recalibrate after changing the bottles. Another situation, if the starters of different lots cannot be, the starters of different lot cannot be mixed, even for same lot of starters. It can't be mixed when the old pair had been used for more than 2 weeks. For the waste bag, you need to make sure that the container of the waste bag is well installed. So this is the correct installation, so we don't block this exit of cuvette from the chamber. If you install in the wrong way, for example, like this, you are blocking the cuvette. The cuvette will be blocked here, and there will be cuvette jam inside the analyzer. Then we will see in the second part some preparation before starting using analyzer in the daily routine. So firstly, how to turn on the analyzer. We need to start the main switch first. So this is the main switch first, and then the sub-main switch 3 seconds later. And then we log into the user software, double click on the Maglumi A100 user in the desktop, and then this window will appear. The username is Snipe, the password also is Snipe. Click OK. And this is the home page of the user software. After you click OK, the analyzer will automatically initialize. So you will see the pipetors priming and the cuvette moving and so on. So check the consumable status manually. You can check it manually on the analyzer. You can also check here in this area if everything is okay. If the color is green, the indicator should be green in the user software. The temperature and voltage indicators also should be green after maximum 30 minutes from turning on the analyzer. Then for the reagent, start loading the reagent you want to use during the day. And when you load the reagent in the reagent area, of course, you need to scan. And of course, at the beginning, remove the reagent from the refrigerator, open the vials one by one and check the bubbles inside the reagent kit. Then scan the reagent kit and load it in the reagent area. When you load the reagent in the reagent area, you will see in the home page of the user software, the slots on the reagent area are displayed with different color, depending on the status of the reagent. So different colors has different meaning. For example, the red means recognition failure. The reagent is not recognized. In this situation, you need to take out the reagent kit and then scan again and load it again into the reagent area. All the other colors means that the recognition is successful. All these colors means that the scan is successful, and now we have these colors has other meanings. For example, the black is expired reagent kit. You need to remove it and replace it. Microbead is mixed after you load the reagent. The mix of microbead in the first vial by the shaker will start automatically and will last after 30 minutes, about 30 minutes. It will display the time. When starting mixing, it will display here 30 minutes. And then the counter will decrease until 0. When it is 0, you can start using the reagent. After that, you can use calibration, quality control, run the samples, and so on, when the time is 0, the remaining time of mixing. Now, after that, you can load the samples. Make sure there is no bubbles in the sample tubes, and then load the sample rack in the sample area. The same thing, when you load the sample rack, you can see in the homepage of the user software the slots of the sample area with different color. Green means the successful recognition of the sample rack. Each sample rack has a switch, a sensor detecting the presence or not of the rack. And also we have the barcode reader to scan the labels of the samples. If it is green, then the sample, it is ready to be used for testing. If it is red, then the recognition fails and you need to remove the rack and try to load again. Then after you load the reagent and check consumables reagent, and you can start running the system test. The system test is the test that we run every day before starting running the samples. So you can check the status of and the performance of your analyzer. If everything is okay, if the results are reliable, if there is the analyzer will provide reliable results. So firstly, the system test contains the 3 steps. The first step is priming. It is priming of pipetter, washer, and chamber. The priming of washer and pipetter are using the wash liquid because these 2 components are using the wash liquid. The priming of chamber is using the starters because starters used by the chamber. The second thing contained in the system test is the BHW test, and the third is the light check test. So we need to run these tests every day. If we are running the light check in our system test, if the light check will be run, we need to load the light check button. For Maglumi A100, it is in any position. You remember for the 2000, we said it is in the 11th or 12th position of the sample area. Anyway, the operation in the user software are as following. So firstly, we choose 3 for priming and 1 for BHW and light check. But light check is not to be run every day. For the system test, it's every day, but the light check is at least, it's recommended to do it every day, but if not, at least once a week. If we don't run the light check, we just input here 0. And then if you stop using the analyzer for more than 5 days, the number of priming will change from 3 to 10. This is one situation. And another situation, if the system liquid is replaced. So if you replace system liquid, you need to prime the more the pipeator and the washer. 10 for pipeator, 10 for washer. And you keep 3 for chamber because it is not using the wash liquid. But if you change the starter only, then you keep the pipeator 3 and the washer 3, and you change the starter to 10 because it is using the starter. So how to run the system test? Enter sample and reagent interface. After you load physically the light check in the sample rack, if you are using the light check, click the sample rack and then click the check the light check. If you are using the barcode, it will be detected automatically as a light check. It will be recognized automatically. If not, click light check here to indicate that it is light check loaded in the position. And then after that, click system test, enter on the top, click system test here, and then this window will appear. Choose the repetition for the priming of pipeator, washer, and chamber, and the number of tests of BHW and the light check. Then click OK, of course, and then confirm. Confirm here. It will display you the configuration for the system test. Click OK to confirm, and then click Start to start the system test. After that, you need to check the results. After the system test finished, check the results. The recommendation, so the results is in the results system test. And you can see here the results for the BHW and the light check. So here for the first step, for the priming, we don't have results because it's just priming. But for the BHW and the light check, we have the results. We have RLU and CV, so we can check them. So check whether the RLU and the CV meet the requirement. For the RLU, for the BHW, the RLU should be between 100 to 1,200. And the CV for BHW should be less than 10%. And for the other side, for the BHW, for the light check, the RLU of light check should be between 450,000 to 650,000. And the CV for the light check, it should be less than 3%. So this is the requirement. If the RLU of BHW or light check or the CV of BHW or light check are not meeting this requirement, you need to take the appropriate action and fix the problem. Because if you want to run the normal sample test later, the results may be not accurate. If you want to see the detail of the results of BHW or light check, choose BHW or light check and click view, and you will view the detail of results. So for the BHW, it is 6 results because we have a kivot of 6 cap. So we said it is 6 tests. So we have 6 RLU. And here we have the mean value of the 6 value and the CV. Same thing for the light check. It is 6 results, 6 RLU. And here we have the mean value of the 6 RLU and the CV. After the system test finished, calibration, QC, and sample can be run when the microbeads mix remaining time is 0. So we can start, for example, the calibration. So here we can see when we need to do calibration, when the calibration is needed. So we can use the different colors to know which reagent need calibration. We can know it from the different colors. So we said that the red means not recognized and the black means expired. So for the yellow means for the green means that the reagent is recognized and calibrated and everything is okay and ready to use. Then we have the 2 other colors, the yellow and the purple. The yellow means a new reagent kit without calibration, which means it needs calibration. And the purple means the calibration is expired. So the purple means it is not new. It is already used, but its calibration is expired and need another calibration. So in case we have the yellow and purple, we need to calibrate the reagent kit. This is from the home page of the main page of the user software. But also we can enter the sample and the reagent interface, and we will see more detail about the reagent. You can see here, we can see more detail. When we enter sample and reagent area, you can see we have the reagent loaded on the reagent area will be displayed here with the name of the reagent, of the parameter, the remaining tests, number of tests, and we have two square here with different color. So this square with different color has meaning also. We can get some meaning from this color. So if the left square is purple, and then it depends on the right square. If it's gray, then means the calibration has expired. If it's the right one is red, the calibration has expired, and there is a second calibration that is on board, that is ongoing, that is running. And if the right one is green, then the calibration has been expired. A second calibration has been executed, but has not been validated. So it is finished, but not validated. When we validate it will turn to green color. This one will turn to the green color, the purple one. And also if we have red colors on the left square, and then on the right square, if we have the gray color, means without valid calibration. If the right one is also red, without valid calibration, but there is calibration in progress, but not finished. If the right one is green, then without calibration, new calibration executed and finished, but not yet validated. So after we validate it, it will turn to green also. So also from the sample and reagent interface, using this square, we can use this square to know when we need to calibrate, when we have red in the left, gray in the right, or purple in the left, gray in the right, we need to calibrate the reagent kit. So how to run the single calibration? In Maglumi analyzers, it is very, very easy to run the calibration. You cannot find another analyzer from other competitors where the calibration is easy like this one, because as you know, we said that in the reagent kit, we have the calibrators in the vial number 2 and the vial number 3. So these two vials has the calibrators, which means that our calibrators are included in the reagent kit and ready to use. So they are already inside, loaded on the analyzers. So we don't need to remove the calibrators from the refrigerator, wait until the temperature of the calibrators reach the room temperature, or maybe reconstitute the calibrators with distilled water or something else with diluent. We don't need to do anything. We don't need to load the calibrators in the sample rack or choose the position where we need to load them and so on. So just click when you decide to calibrate. You know that the calibrators are already included in the reagent kit and inside the analyzer. So you just enter the sample and the reagent interface, select the parameter you want to calibrate, and then click calibrate and then confirm. Click OK, and then the calibration will start. It takes few seconds to run the calibration in Maglumi analyzers. After how to run the batch calibration. So if you want to calibrate more than one parameter in the same time, run together more than one calibration. Also in the sample and reagent interface, click batch calibrate. This window will appear and will display a list of all the reagent loaded in the reagent area. And then select all the parameters you want to calibrate from this area, and then click OK, and then all the parameters selected will be calibrated together in the same time. After the calibration launched, you need to check the results after the calibration finished and validate the calibration if the results are good. So in order to check the calibration, you can enter the service, the sample and reagent interface, select the parameter you want to check and click view, and this window will appear. So you can see the calibration curve in the black color between the two green lines, the two green curves. So in case this is your calibration curve, and this is the results for the calibrator low, which is calibrator 1, it is the low, and this one, the second, is the high. You can see the concentration, and you can see the duplicate. So 2 times for the first one and 2 times for the second one. And then you can see the mean value, the CV, and the deviation for each calibrator, for the calibrator low and calibrator high. And then you can compare your results to the requirement. This is the requirement for the CV and for the deviation. So check whether your CV is less than 15% for both calibrator 1 and calibrator 2. And also check the deviation. If the deviation is between minus 70% and plus 70% for both calibrator 1 and calibrator 2. And also you can use the second formula, the deviation 1 minus the deviation 2 is between minus 30% and plus 30%. If the CV is less than 50%, the deviation 1 and 2 are both between minus 70% and plus 70%, and the difference between the two deviation is inside the interval minus 30% plus 30%, your calibration is good and you can validate it. To validate it, to start using this new calibration curve, you need to validate. So click validate here. If the result doesn't meet the requirement, you click reject to reject the calibration. And if you want to use the new calibration to calculate the results you run in the same day using the previous calibration, you also got some results using the old calibration. And now you need to recalculate the results obtained by the old calibration by using the new calibration curve. You can use this one, recalculate associated samples. So what is the meaning of this one? It is, for example, during the daily routine, the end user, the doctor, ran three samples for TSH, for example, and he got the 3 results for his samples. Results 1, results 2, and results 3. So concentration 1, concentration 2, and concentration 3. And according to his experience, and he know according to the normal results, he think that these results are not good, and because of the calibration. So the reason is the calibration. So he decided to recalibrate the TSH reagent kit and to fix the problem by the calibration. For example, this is the calibration used the first time to run this sample test. So this is, for example, the results. So this is the first, for example, the first RLU, and this is the first result, C1. This is the second RLU, and this is the second results, second concentration, C2, and this is the third, C3. And he is not satisfied by these results, and he thinks that the problem is in the calibration. So he decided to recalibrate the reagent kit. So after making recalibrating the TSH, he will get a new calibration curve, of course, different from the previous one. So the end user can use the new calibration curve to obtain the results for the 3 tubes, the 3 samples, without running again the test, without consuming the reagent, just by choosing the function to recalculate the associated samples in order to get the results for the samples just calculated from the new calibration curve. In this situation, this is the results for the first tube using the new calibration curve. It will use the same RLU obtained by the previous testing. So it doesn't, the RLU is not impacted by the calibration curve. So the RLU are correct for the samples. Just the calibration curve is changing. So we can obtain the new results, the C1 for the first tube. And using the second RLU, we can obtain the second, and the new calibration curve, we can obtain the new results for the second tube. And using the RLU for the third test, third sample, and the new calibration curve, we can obtain the new results for the third tube, for the third sample. So this is the meaning of recalculating associated sample using the new calibration curve. So now need to run the test from the beginning and consume reagent again. After you validate your calibration, then you can, for example, run the quality controls. But for the quality controls, if you are using the quality controls, if you are the first time you use the quality controls, you need to add the information about the quality control in the user software. So you enter the definition interface. Quality here, click control, and you can see here the list of control. So this is the control already used, already added in the software. If you want to use, if the quality control already exists, you can use it. If not, you have to add it by clicking add. And then you can, this window will appear, and then you enter the information about your quality control using the insert, using the technical sheet of the quality control. The main information of the quality control are the name. So for each quality control, you have a name and the lot number and the expiration date. Then you select which parameter used with this quality control, which parameter is controlled by this quality control. Select it. It can be one, it can be more than one parameter that are controlled by the same quality control. Then the other thing you need to add is the information about the quality control, important information. Click add, and this window will appear to add the range of your quality control you obtain from the insert of the quality control, the range, the normal range of your quality control, the target value, the target SD, and the target CV. So for this information, for the name, the lot number, the range, the target value, the SD and CV, all this information you have in the insert. So for the SD, you can calculate it. It is the upper band minus the target value divided by 3. So the upper band is this, minus the target value you get from the insert divided by 3. That is the target SD.